Okay, dear students, and here are important rules that you have to keep in mind. The first remark is that cosine theta and sine theta are both bounded between -1 and 1. Why? Let's see why sine and cosine should be bounded between -1 and 1. If we have a trigonometric circle, as you see here, divided into 4 quadrants, we know that cosine theta is represented by the abscissa. For example, if here is angle theta and here is point M, then cosine theta is representing the abscissa of point M. So if M is here, then the abscissa should be that way. So cosine theta is moving on the axis of abscissas, but it's bounded from here till here. So it's bounded from -1 till 1. Similarly for sine theta, which is represented by the ordinate of this point M, and the ordinate goes from here till here, and so sine of any angle in the trigonometric circle is bounded between -1 and 1. So that's why sine and cosine are always bounded between -1 and 1. So we can't have a cosine for an angle that's equal to 3 point something, or 4, or 2, or -2, or -3, or -5, or whatever, while there is no condition on the tangent. Okay, so tangent theta has no condition. The condition is only on sine and cosine, as you see here. Now, more important rules, which is concerning cotangent theta, for example, and this is the first time we talk about cotangent theta. Cotangent theta is indeed the reciprocal of tangent theta, which is cosine theta divided by sine theta. Because tangent theta is sine divided by cosine, then cotangent, which is the reciprocal, is cosine divided by sine. And the most important trigonometric rule is this: cosine squared theta plus sine squared theta is equal to 1. And again, here is the proof on the trigonometric circle. So as you see, if this is theta, this measurement from here to here represents sine of theta, and from here to here represents cosine of theta. And if we apply Pythagoras theorem in this right triangle, we notice that sine squared theta plus cosine squared theta is equal to the hypotenuse squared, and the hypotenuse is indeed equal to the radius, which is 1, and thus 1 squared is equal to 1. And this is the most important rule in trigonometry. And this rule gives us more important rules that we are going to use later. The first one says that cosine squared theta is equal to 1 minus sine squared theta, and sine squared theta is equal to 1 minus cosine squared theta. So this is the initial or the original rule, and these are resulting from it, just taking one of them to the other side to calculate the missing. Here is also an important rule that you have to keep in mind. It's related between cosine and tangent. It's cosine squared theta equal to 1 over 1 plus tangent squared theta. Some write that 1 over cosine squared theta is equal to 1 plus tangent squared theta, as if making reciprocal for both sides. Also, sine squared theta is equal to tangent squared theta over 1 plus tangent squared theta. So these are to be kept in mind very carefully. Cosine and sine are bounded between -1 and 1. Tangent is equal to sine over cosine. Cotangent is the reciprocal of the tangent. Cosine squared theta plus sine squared theta is always 1. Using this rule, I can deduce these two rules. Cosine squared theta, in case I want a relation between cosine and tangent, I have this relation. And in case if I want a relation between sine and tangent, I have this relation, and I can use it in solving exercises. Now here are the proofs for the last two rules. Why is sine squared theta equal to tangent squared theta over 1 plus tangent squared theta? Let's start decomposing this one. tangent is sine over cosine. So tangent squared theta is sine squared theta over cosine squared theta. And in the denominator also, 1 plus tangent squared theta is 1 plus sine squared theta over cosine squared theta. Now I make the same denominator in the denominator here. So multiplying 1 by cosine squared theta and making the same denominator, you will get sine squared theta over cosine squared theta over cosine squared theta plus sine squared theta. We can simplify as follows. Cosine squared theta plus sine squared theta is 1. Thus we will get sine squared theta over 1, which is sine squared theta. Now for cosine squared theta, we have to prove it equal to 1 over 1 plus tangent squared theta. So again, we have to decompose tangent squared theta into sine squared theta over cosine squared theta, making the same denominator also. We will have 1 over cosine squared theta plus sine squared theta, all of it over cosine squared theta. Now, using this rule by putting 1 over 1, you can put it like this, over 1, using the extreme with the extreme over the mean with the mean, we will get cosine squared theta over 1, which is cosine squared theta. And here are the proofs of these two important rules.